Alright, we're trying to prove the opposite angles are congruent here. Alright, we're trying to show that these opposite angles, I'll call this angle 3, you'll see why later. We want to show that angle 1 is congruent to angle 3. Alright, so we start with our given information. We're working with a parallelogram, so we know that these sides here are parallel to these sides here, and this side is parallel to this side. So that's our given information. Now, how do we jump from 1 to 3? In this proof, what we like to do is extend this side a little bit further. See how I added that line? And we're going to put angle 2 up there. And the question is, what do you know about angles 1 and 2? The answer, they're congruent. Why? They're corresponding angles. I'm going to write corresponding angles postulate. Has to deal with parallel lines. If you don't know what the corresponding angles postulate is, Google it or look back in your notes. You need to know it. And it'll help make you understand this proof a little bit better. Alright, so I jumped from 1 to 2. The question is, how is angle 2 related to angle 3? The answer here is that they're alternate interior angles, and they're congruent. Angle 2 is congruent to angle 3 by the alternate interior angles theorem. If you don't know what that is, Google it, look it up in your notes. You're not going to understand this proof unless you understand what's going on in this second column here. Okay? If you don't understand what these things are, this is just going to seem like a foreign language that you're trying to memorize. Look these up and it'll make more sense. Lastly, we went from angle 1 to angle 2, and then we're going to jump down from angle, it says angle 1 is equal to angle 2, angle 2 is equal to angle 3, and so 1 is like inherits that, it's equal to angle 3 as well by the transitive property. If 1 equals 2 and 2 equals 3, then 1 has to equal 3. So angle 1 is congruent to angle 3 by the transitive property of congruence. Alright? And that's really the proof right there. It's that you can start with the parallel sides and you just hop around from 1 to 2, 2 to 3, and so therefore 1 and 3 are equal.